On February 8, 1587, Mary, Queen of Scots, met her end. After 19 years in captivity, her official records vanished and her decline was blamed on circumstance. But scientists now probing her burial artifacts have uncovered chemical signatures and DNA traces that contradict centuries of rumor. Was her suffering a product of hidden illness, of deliberate neglect, or of something darker? The truth was preserved, molecule by molecule, waiting to be revealed. Before any scientific claim could be made about Mary, Queen of Scots, every artifact linked to her name underwent a rigorous chain of custody protocol. Archivists and conservators from cathedral repositories and royal collections coordinated permissions, ensuring each textile fragment, coffin residue, and personal relic was handled under strict guidelines. Sampling agreements set clear boundaries, including minimal intervention, no destructive testing without written approval, and every movement logged in repository records. Each item received a unique identification code and custody date, entered into imaging logs alongside high-resolution scans and microphotographs. Lab intake began only after conservators confirmed the state of preservation and verified provenance through archival paperwork. In some cases, items traveled in climate-controlled containers, accompanied by custodial staff who documented handovers with digital timestamps. Curators kept parallel records, cross-checking against historical inventories and previous conservation reports. At the laboratory, samples were catalogued under anonymized codes to prevent bias during analysis. Intake sheets recorded the precise origin of each fiber, wax flake or metallic particle, with chain of custody signatures required at every transfer point. Environmental controls and contamination blanks were prepared in parallel, following the same intake procedures as the historical materials. These protocols, while painstaking, form the backbone of credibility for any findings that follow. Every sample's journey, from cathedral crypt to laboratory bench, was documented in detail, establishing a foundation of trust before any test tube or microscope came into play. The result is a record as meticulous as the evidence it protects, ensuring that what is revealed about Mary's final days rests on unbroken lines of proof. Subscribe for more historical investigations. Inductively coupled plasma mass spectrometry revealed a startling pattern in the samples linked to Mary, Queen of Scots. Textile fibers, coffin residue, and wax fragments all showed lead, mercury, and antimony levels, far above those found in controlled textiles from the same era. The lead to mercury ratio was nearly triple the baseline for 16th century burial cloth, while antimony, rare outside of medicinal or cosmetic use, registered at concentrations not seen in ordinary funerary fabrics. Analytical chemists traced these metals to compounds historically used in cosmetics and ointments favoured by European nobility. Lead-based powders and mercury-lace balms, popular for pain relief and skin whitening, were standard in royal routines. Medical historians reviewing the data noted that chronic exposure to these substances could easily explain symptoms described in Mary's letters: persistent fatigue, joint pain, and swelling. The toxic metals disrupt nerve and immune function, producing the very decline documented in her correspondence. The presence of antimony in particular raised questions about her treatment for insomnia and emotional distress, because antimonial preparations were often prescribed for grief and sleep. The concentration profiles plotted against historical controls painted a picture of cumulative poisoning, whether from daily cosmetics, medicinal regimens, or both. Forensic commentary underscored that these findings were not incidental. The levels detected in Mary's burial textiles, compared to other noble samples, pointed to long-term exposure rather than a single event. The chemical evidence, measured and verified, offered a silent testimony to the physical toll exacted by the remedies of her time. Sequencing efforts targeted environmental DNA preserved in the folds of burial textiles and coffin residues. Laboratory controls ruled out modern contamination, with negative blanks matching background levels. The DNA fragments recovered showed patterns of cytosine deamination typical of ancient samples, supporting their authenticity. Taxonomic analysis identified dominant bacterial groups, consistent with chronic skin and respiratory colonization. Staphylococcus, Cutibacterium, and Streptococcus species were present at levels far exceeding those found in comparative samples from non-royal burials of the same era, showing clear overrepresentation. Statistical models run against a database of 16th century textile microbiomes confirm the overrepresentation of taxa linked to long-term dermal inflammation and impaired immune response. These findings align with descriptions of Mary's persistent rashes, swelling, and recurring respiratory complaints. Forensic environmental DNA specialists noted that such microbial signatures often result from years of confinement, poor ventilation, and repeated minor infections left untreated or exacerbated by stress. The dataset included rare anaerobic bacteria, suggesting periods of oxygen exposure, likely a byproduct of heavy bedding and limited during the latest. Together, shape not exposure, but by the realities of life in isolation, revealing layers. Pigment analysis of thread fragments taken from Mary's burial textiles revealed something unexpected. Traces of rare mineral dyes, including ultramarine and verdigris, embedded within the weave. These pigments, sourced from lapis lazuli and copper acetate, were far too costly and symbolically charged for routine decoration. Material culture historians identified the color patterns and motifs as matches for secret emblems Mary was known to use in her private embroidery. One recurring design, a crowned thistle entwined with a broken chain, appeared in both the pigment fingerprint and encoded messages deciphered from her surviving letters. The dyes themselves carried meaning. Ultramarine was reserved for sacred or royal commissions, and verdigris was associated with rebirth and hope. Forensic comparison with documented Stuart-era textiles confirmed that the specific composition and layering of these pigments were unique to Mary's personal effects. The evidence pointed to embroidery as more than ornament. It became a covert language, stitched under watchful eyes to signal allegiance or defiance. Experts in historical symbolism noted that these motifs often doubled as ciphers, communicating intent to trusted recipients when overt speech was impossible. The threads, saturated with coded color, offered a glimpse of Mary's agency within confinement, a silent assertion of identity and purpose preserved at the molecular level long after her voice was silenced. Chemical analysis of the Coffin residues revealed an unexpected fingerprint, compounds that do not match any formula found in English embalming manuals from the late 16th century. Instead, the resin markers and aromatic profiles align with preservation techniques favored by French nobility, involving exotic plant extracts and rare balsams. Forensic chemists documented the presence of benzoin and storax, resins imported from the Levant and more commonly used in continental burials. Alum and pitch, standard in English practice, were present only in trace amounts. This departure from local tradition raises questions about who oversaw Mary's final preparations and under whose authority such foreign substances were introduced. An embalming historian reviewing the results noted that the precise blend of resins and aromatics would have required specialized knowledge and access to continental trade networks, resources not typically available in an English royal prison. The evidence points to a burial process that was, in its chemistry, neither wholly English nor quietly conventional. The coffin itself became an artifact of cross-border influence, and perhaps of contested custodianship. Subscribe for more historical investigations. No complete medical ledger from Mary's captivity has ever surfaced. Instead, the official record is a patchwork, fragments of correspondence, gaps in royal logs, and inventories that trail off without explanation. Archivists working with these materials describe a landscape shaped as much by omission as by preservation. The absence of systematic medical entries, especially for a prisoner of Mary's status, stands out against the more detailed records kept for other Tudor-era figures. Some custodians suspect deliberate redaction, pointing to periods where political sensitivity ran highest, and documentation thinned to a trickle. Museum stewards and cathedral archivists now face a dilemma: how to balance the drive for discovery with the ethics of handling relics tied to living faith and national memory. An ethicist consulted on the project urges caution, warning that every new test, however non-invasive, carries the risk of erasing contextual traces or introducing modern contamination. Calls for replication and independent verification echo across institutions, with proposals for open access protocols and international review. The hope is that by insisting on transparency and repeatability, future research can move beyond rumor and conjecture, establishing a model for investigating historical mysteries while honoring the silences that history has left behind. Centuries later, science still finds secrets in Mary's remains that official records refuse to tell. As technology sharpens, history's silences grow thinner. The body can outlast the story, and sometimes it contradicts it. The past isn't buried, it is waiting to be decoded. Subscribe for more untold investigations.